In this video, I'll show you how to solve the ALEKS problem called Calculating the Heat of Reaction from Bond Energies and Lewis Structures. To help you solve this problem, you are going to want to go to ALEKS's Data tab over here and open up the table of bond energies. I've got the table of bond energies pasted in this problem to make it kind of easier for us to access, but you're going to open that up for yourself. We're going to be taking data from these different bond energy tables. So the equation that we're going to be using to perform this calculation, the change in energy or enthalpy of the reaction, this is going to be equal to the bonds that are broken. I'm just going to write broken bonds. The bonds that are broken, and we're going to subtract from that the bonds that are made in this chemical reaction. So what we're going to do is add up the energy of all of the bonds that we're breaking, and from that we're going to subtract the energy of all the bonds that we are making. Now the bonds that we are breaking, those are all the bonds in the reactants, and the bonds that we're making, those are the bonds in the products. And what we want to do is make sure we're paying attention to stoichiometric coefficients when we're looking this up. So in this reaction, we're not just breaking an HCl bond, we are breaking two HCl bonds, and we're making two HBr bonds. So I'm going to try to kind of write this out. For our broken bonds, we have two of the HCl bonds, and then we have one of that bromine-bromine bond, the Br2 bond. And then from that, we're going to subtract two of those HBr bonds. That's our product, one of our products, and also one of the chlorine-chlorine Cl2 bonds. So now it's just a matter of finding these values in the data tables, looking them up. So here is HCl. I know that's one of our molecules, and HBr, that's one of them as well. And we also have Br2. And we have Cl2 as well. So those are the values that we're going to be using to plug in and calculate delta H. So I'm just going to start doing that. 2 times the value of an HCl bond, it is 431. I'm going to leave the units off for now, but we'll just add them when we get to the end of the problem. HCl has an energy, the HCl bond has an energy of 431 kilojoules per mole. And then our other reactant, Br2, this has the energy of 194 kilojoules per mole. So those are all of the bonds that we are breaking in this reaction. And then from that, we're going to subtract the energy of all the bonds that we're making. Here's our HBr bond. That is 366 kilojoules per mole. And the chlorine-chlorine bond right there, that's 243 kilojoules per mole. And now we just need to put this into a calculator, and that'll give us our answer. 2 times 431 plus 194, that's the energy of all of the bonds that we have to break. And then from that, I'm going to subtract 2 times 366 plus 243. And this gives me a bond enthalpy of 81. And those units are kilojoules per mole. For whatever reason, I feel a little bit not super confident about that answer. That number seems a little bit on the small side. And so if I was actually about to plug this into ALEKS, I'd probably just double check, make sure that I got all the numbers in the correct spot. And I also double check my math because these numbers are usually in the hundreds. And I want to let you know that sometimes these numbers are going to be negative, sometimes they're going to be positive. Make sure whatever sign you get that you are definitely including that when you enter your answer in. Negative versus positive does make a difference.